Today we are going to learn about Python data classes, simplifying class development. We will explore how to implement data classes to streamline class creation, reduce boilerplate code, and enhance code clarity.
Welcome to our exploration of Python data classes. Data classes were introduced in Python 3.7 as a way to automate the creation of classes for storing data, reducing the amount of boilerplate code you need to write. With data classes, you can define a class with attributes, and Python will automatically generate special methods like _init_ and _repr_. This not only simplifies your code but also enhances readability and maintainability. In this video, we'll delve into how data classes work, how you can leverage them in your projects, and what advantages they offer over traditional classes. Let's start by understanding the basics of setting up a data class in Python. To get started with data classes in Python, the first step is to import the data class decorator from the data classes module. This decorator is applied to a class to indicate that it should be treated as a data class. Here's a simple example. From data classes, import data class. Once imported, you can define a data class by marking a class with the @DataClass decorator. For instance, consider a class to represent a point in 2D space. You would define it as follows: @DataClass class point, x, int y, int. Here, x and y are attributes of the class. The @DataClass decorator automatically adds an _init_ method, allowing you to instantiate a point object with x and y values. The class is now ready to use, with Python handling the creation of standard methods behind the scenes. Data classes offer a convenient way to define default field values and specify data types. This is achieved by assigning default values directly in the class definition. For instance, you might have a class representing a car with a default color. @DataClass class car, make, str model, str color, str equals red. Here, any instance of car will have red as its default color unless specified otherwise. Data types can also be explicitly stated, providing clarity and aiding tools like type checkers. Additionally, the field function allows for further customization, such as setting default _factory for mutable types. This approach not only streamlines method generation but also enhances code reliability and readability.
One of the standout features of data classes is the automatic generation of special methods like _init_, _repr_, and _eq_. The _init_ method is created to initialize object attributes, allowing for easy instantiation with arguments corresponding to class attributes. The _repr_ method provides a readable string representation of the object, useful for debugging. Additionally, _eq_ is generated to compare data class instances based on attribute values. While these methods are automatically created, you can customize them if needed. This automation significantly reduces the amount of boilerplate code you need to write, freeing you to focus on the logic that matters most in your application. Traditional Python classes require manual implementation of methods like _init_ and _repr_, leading to repetitive and verbose code. In contrast, data classes streamline this process by automating method generation, drastically reducing code overhead. They enhance readability and maintainability by focusing on what the class represents, not how it functions internally. However, traditional classes offer more flexibility for complex behaviors. Data classes are ideal for scenarios where classes primarily store data, such as configuration objects or database models. While data classes improve efficiency, it's crucial to consider potential performance impacts, especially with large-scale applications.
Data classes offer flexibility to add custom methods that extend their functionality beyond storing data. You can override generated methods like _init_ if additional processing is required during object creation. Post-init processing is another powerful feature, allowing you to define a _post_init_ method that runs after the auto-generated _init_. This is useful for validation or calculating derived attributes. Additionally, fields can be customized using the field function, enabling features like default factories or metadata storage. Data classes can also integrate seamlessly with libraries like JSON or Sclalchemy, enhancing their applicability across various contexts.
Data classes excel in scenarios where simplicity and clarity in data representation are paramount. They're perfect for configurations, database models, and any context where objects primarily hold data. Common use cases include APIs, data processing applications, and object relational mapping. Despite their advantages, data classes have limitations, such as not supporting inheritance well and potentially leading to large memory footprints with extensive fields. They may not be suitable for complex business logic or applications requiring intricate class hierarchies. Understanding these limitations helps you balance simplicity with functionality, choosing the right tool for each task. To solidify our understanding, let's explore some real-world examples of data classes in action. Consider a scenario where you need to model a user for an application. Using a data class, you can define attributes like username, email, and password with minimal code. This simplicity extends to applications in machine learning, where data classes can encapsulate model parameters or configurations. As we walk through these examples, notice how data classes enhance productivity by reducing boilerplate and focusing on the actual data structure. Implementing best practices, such as clear type annotations and appropriate use of default values, maximizes the benefits of data classes in any project. In conclusion, Python data classes offer a powerful way to simplify class development by reducing boilerplate code and enhancing code clarity. They're ideal for scenarios where data storage is the primary purpose, improving the development workflow by automating method generation. As you continue to explore Python, consider how data classes can streamline your projects and enhance productivity. The future of data classes looks promising, with potential for further enhancements and integrations. We encourage you to experiment with data classes in your work, discovering firsthand the transformative impact they can have on your coding practices.